Welcome back, everybody. Today I want to talk about stable sea levels and happy Komodo dragons. Now, the recent news has been that the Komodo dragon is endangered due to rising sea levels, and that's basically based on one study by Jones in 2020 that says up to 87% of their habitat could be reduced just by 2050, and this is due to climate models that suggest more CO2 will cause higher sea levels. But has more CO2 caused dangerous higher sea levels? Well, what I'm going to show you is the evidence says no. Now, sea level changes are complex. It requires evaluating all the science. But climate model projections are blinkered by selective science that's driven by rising CO2. Honestly trusting all the science suggests that there are thriving, happy Komodo dragons. Now, I do not want to see Komodo dragons go extinct on my watch. They are amazing creatures straight out of Jurassic Park. They can get to grow 10 feet in length, weigh up to 300 pounds, and they will gladly eat humans. Now, fossil evidence shows that Komodo dragons existed in Australia about 4 million years ago, and that was when Greenland lacked an ice cap and sea levels were much higher. Now, today, they're restricted naturally to a small group of islands in Indonesia's Sunda Islands. During the last 1 to 2 million years, the Earth experienced periods of alternating glaciers and melting glaciers. During the growth of a glacier, sea level fell to a low stand that had reached about 400 feet lower than what it is today. When the glaciers melted, it would reach a high stand. The last high stand, about 2,500 to 6,000 years ago, had sea levels in the Pacific reaching 13 feet higher than today. Yet the Komodo dragons didn't go extinct. Now, in addition, as glaciers grew, the weight of those glaciers caused the land beneath it to sink. And as it did that, the viscous subsurface would ooze to the sides and cause the land outside those glaciers to rise in what is called a forebulge. When the glaciers melted, sea level rose, as did the land beneath the glacier started to rise, and the forebulges would sink. And this affected sea level around the world. So if you looked at Canada, where the glaciers were at their maximum, several thousand feet above Chicago, we see the tide gauges there will tend to record a falling sea level because the land is rebounding from the glaciers and rising faster than sea level is. And if you look at the United States that was affected by the uplift of the forebulge, that part of the United States sea gauges are now falling, and it makes the average sea level change at the tide gauges look like it's above average. Around 2,800 years ago, sea levels in Oceania began falling below the present day levels. And we know this from sediment studies as well as fossil reefs. The fossil reefs that had grown to much higher elevations during the high stand now were left high and dry during the low stand. And ocean currents and waves continue to chip away at the base, creating these mushroom shapes of fossil reefs. Now, these mushroom-shaped reefs are found all around the world. And in the Indian Ocean, one study showed that between 100 and 700 years ago, sea level was about 4.5 feet lower than the present. Now, that low stand happened during the Little Ice Age and is associated with sunspot minimums, growing glaciers, cooler ocean waters, and, surprisingly, a slight rise in CO2 concentrations, something that climate models cannot reproduce. One popular explanation for this falling sea level is called equatorial Pacific siphoning, And that says that as the forebulge reduced and dropped, waters left the equator to replace that forebulge. Now there's ample evidence of little ice age shifts from high stands to low stands, revealed by micro-atoll formations. There are species of coral that grow in a spherical shape, and they'll maintain that shape until they reach the surface of the ocean. They can even withstand a few hours of exposure to the air during low tide. But when sea levels fall, they're exposed at longer and longer times, and the tops die and are eroded away, and you're left with this micro-atoll hat shape. Now the ocean floor is constantly spreading, and when the plates collide with other plates, these ocean floors dive down in a process known as plate subduction. And this generates volcanic islands, of which the Komodo Dragons Islands were formed, and it affects local sea levels. In that region, one of the most explosive and devastating volcano in recent memory was Krakatoa in 1883. Now, to see how these volcanic islands are formed, we can see when an ocean plate dives down, it eventually gets to a place where it melts, and it provides magma that rises and creates a volcano. At the same time, it can cause the overlying plate to uplift, such as seen in the Komodo region. There, it's been measured that the islands in these regions have been rising by about 0.5 to 1.5 millimeters per year. And that would be enough to offset any rising sea level that's been attributed to climate change. But it's not always smooth. Sometimes these subductions cause earthquakes. And in the Solomon Islands in 2007, the shoreline was raised 10 feet, leaving these coral high and dry. Now, not all volcanoes are causing uplift. When they lose their source of magma, they will begin to sink. When a volcanic island is first formed, a fringing reef will form around its edges. As the volcano sinks further, a lagoon forms between the island and what's now called a barrier reef. And as the volcano sinks even further, it's now called an atoll, where there's just an empty lagoon surrounded by a ring of several islands formed by reefs. Now, this is an example of volcanic islands with fringing reefs. And this is an example of the Funafuti Atoll, which consists of 29 island reefs. And photographic evidence going back 118 years compared with today have shown that the majority of those islands have enlarged. And there's no evidence of heightened erosion over the past half century that has been predicted by climate change. Now, the Maldives Island in the Indian Ocean, about 80% of their atoll islands rise only about a meter above sea level. And so the Maldives was considered one of the most vulnerable nations to climate change. And to dramatize that whole thing, the cabinet of the Maldives signed some documents for climate change underwater. When asked what they were trying to do, what do they hope to achieve? They said, we hope not to die. But other people questioned that, thinking that it was mostly a stunt to help get funding to help support their growth of an artificial island called the Huhumali that will be 2 meters above sea level, created by pumping ocean sediments into this area. And that work began in 2004. So obviously they weren't worried about dying, but more about attracting tourist dollars. Now, sinking land, sinking volcanoes, cause what we call subsidence, and that obscures our ability to determine exactly what's causing this observed rise in sea level. Are tide gauges measuring a rise due to what climate models are saying is due to warming of the oceans? Or are tide gauges in a position where the land is sinking and causing sea level to appear to be rising? Now, subsidence can be caused by several different causes. It can be caused by glacial isostatic adjustments as a forebulge starts to reduce. As people move into certain delta areas, they extract the groundwater, causing the land to sink. Or building on these areas causes the sediments to compress and sink even further. With the age of satellites, we are now able to use global positioning systems to help us tease apart how much the land's vertical motion is changing and how much the sea level is changing. Now, a recent study by Boretti in 2020 took advantage of GPS data to determine the absolute sea level rise in Oceania. They looked at 5 long-term tide gauges from Australia to Hawaii and observed the relative sea level, which amounted to about 1.3 millimeters per year, and then subtracted the amount of subsidence to get the absolute rate of sea level rise. And by doing that, it looks like sea level in this area has only been rising by 0.125 millimeters per year. That means in 100 years, the sea level would rise by ½ inch. And they also looked at acceleration. If growing CO2 is causing sea level to accelerate faster and faster, then we should see acceleration. Yet there was really an insignificant rise in acceleration, rising only 0.0049 millimeters per year every year, which would mean in 100 years, it would only add 0.5 millimeters per year to the annual rise in sea level. Now, this lack of an accelerating rise in sea level has been noted for 15 years, and in fact, many studies that don't get the clickbait of social media have been telling people that sea level has been decelerating. Most of the United States tide gauges have been decelerating and sea level rise since 1930. And we see study after study has shown the same thing. There has been no significant acceleration in sea level rise, which contradicts what the climate models are saying. And still, the government of Maldives is pushing for more funding, and just recently said for us small states, it's not easy. By the time financing is found, we'll be underwater. But there's no evidence of that being the truth. Finally, there's another level of complexity that I want us to understand. Ocean oscillations cause water to slosh back and forth across the Pacific. Now with satellite data, we could see that sea levels along the west coast of the Americas had been falling for a decade. In contrast, around Oceania, sea levels had been greatly rising, which created alarm in a lot of people on those islands. But then over the next 10 years, between 2010 and 2019, the water sloshed backwards. And now, in Oceania, and where the Komodo dragon is living, sea levels have been falling. Now, despite all the observed evidence contradicting the catastrophic speculation from climate models, the media is true to its stated mission, and it's trying to make every event a climate crisis. Again, The Guardian links rising sea level, climate crisis, and extinction. And even our national public radio joins in the extinction and climate crisis bandwagon, despite what all the science says. Our democracy will fail if investigative journalism becomes so biased the public is kept scientifically naive. And unfortunately, mainstream media increasingly pushes bad clickbait science, such as Jones 2020. Up next, I'm going to look at how CO2 cools the planet. Until then, embrace the renowned scientific Thomas Huxley's advice that skepticism is the highest of duties and blind faith the one unpardonable sin. And if you appreciate the science clearly presented here, science rarely presented in and obscured by mainstream media, then please give it a like, share with as many people as possible, subscribe to my channel, and maybe read my book, Landscapes and Cycles, An Environmentalist Journey to Climate Skepticism. Thank you.